It's a pleasure to share ideas with you at the Unither Nanomedical and Telemedical Technology Conference. If you have looked at or attended this conference for 2 years or maybe 3 years, it's really quite remarkable how fast the actual pace of change is. What started as somewhat theoretical ideas are already gaining traction in actual systems. They're still experimental, but they're actually working in vivo. And it's a very exciting area. It's on the cutting edge. In my mind, it's the third bridge to radical life extension. Dr. Grossman and I have written a couple of books which talk about these three bridges. The first bridge being what you can do right now, and that's the topic of another speech, but there's actually a lot more that you can do right now to slow down aging processes, and that's a moving frontier. The second bridge, which United Therapeutics itself, Martine's company, is a leader in, biotechnology, is the reprogramming of the information processes underlying biology. Biology is inherently an information process, but we didn't actually consider it that way. It was health and medicine and the related field of biology. It was basically just hit or miss. It was a grab bag of accidental discoveries, and as such, it progressed linearly. Now it's become an information technology. We have the software of life, the genome, which itself was an exponential progression in its collection. We have the means of changing genes in a mature individual, not just a newborn. We can turn genes off with RNA interference. We can add new genes with new forms of gene therapy, one of which United Therapeutics is in fact a pioneer in. United Therapeutics takes cells out of the body, lung cells, adds a new gene in vitro, inspects it got done correctly, then replicates that cell a millionfold. That's another new technology, injects it back into the body, goes through the bloodstream and ends up back in the lungs. So these are now your cells with your DNA, but with a new gene. And this has cured pulmonary hypertension in animal experiments. It's undergoing human trials. So we have the means now of updating this outdated software of biology. I mean, how long do you go without updating the software on your cell phone? This is probably updating itself as I speak, but I'm walking around with outdated software, and that's not a metaphor. That evolved thousands or millions of years ago, and it's out of date. The fat insulin receptor gene says, hold on to every calorie because the next hunting season may not work out so well. I would like to tell my fat insulin receptor gene, you don't have to hold on to every calorie. I'm confident I will have calories tomorrow. And in fact, that was done in animal experiments near where I'm speaking at the Joslin Diabetes Center. They turned that gene off. And these animals ate ravenously and remained slim, and it wasn't a fake slimness. They didn't get diabetes, they didn't get heart disease. They lived 20% longer. They got the benefits of caloric restriction while doing the opposite. There's several pharmaceutical companies rushing to bring that to the human market. And we can design these inventions on computers. We can test them out on biological simulators. So health and medicine, which up until recently was not an information technology, has now become an information technology. Why is that important? It's important because information technologies progress exponentially, not linearly. And that's not an approximation. They progress very predictably and precisely at an exponential rate. And I'll show you some examples of that just to show you how pervasive it is. But once something becomes an information technology, it progresses exponentially. Why is that different from linear progressions? Well, if you take 30 steps linearly, 1, 2, 3, 4, 5, you get to 30. Take 30 steps exponentially, 2, 4, 8, 16, and that reflects the reality of information technology, you get to 1 billion. And this is not an idle speculation about the future. When I was a student at MIT, we all shared a computer. It took up half a building. In fact, I went to MIT because it had a computer. Most schools at that time didn't have one. It cost tens of millions of dollars, took up half a building. This computer is 1 million times cheaper, 100,000 times smaller, and 1,000 times more powerful than that computer we all shared when I was a student. That's a billion-fold increase in price performance. MIPS per dollar, bits per dollar, bits of communication per dollar. And we'll do it again in the next 25 years. And it's not just a matter of these devices we carry around. It affects everything we care about, like health and medicine, which has now become an information technology and is now subject to this phenomena, which I call the law of accelerating returns. So biotechnology, which is really the reprogramming of the information processes underlying biology, away from disease, away from aging, it's in an early stage today, but now that it's in information technology, it will progress exponentially, doubling in power about every year. So these technologies will be 1,000 times more powerful in 10 years, 1,000,000 times more powerful in 20 years. The golden era of biotechnology is perhaps 15 years away. According to my models, we'll then be adding more than a year every year, not just to infant life expectancy, but to your remaining life expectancy. So that's not a guarantee of living indefinitely, but it's a tipping point. The sands of time will start running in. We'll have to change our metaphors. So that's the second bridge. This conference is about the third bridge, which is also an information technology, applying nanotechnology to health and medicine. Because even if we reprogram biology away from disease and away from aging and optimize biology, it's still a suboptimal system. It's still based on proteins, which are folded up linear sequences of amino acids, a limited class of materials, and a limited class of kinds of reactions. An optimized biological system will still be far inferior to what we ultimately can re-engineer as we understand the basic principles of biology. And that's the promise of nanotechnology. Another exponential progression is the shrinking of technology. I've calculated that to be about 100 in 3D volume per decade. So systems will be about 100,000 times smaller than they are today in 25 years. So what fit inside a building when I was a student now fits in my pocket and is 1,000 times more powerful. What now fits in my pocket 25 years from now will fit inside a blood cell. So the quintessential application of nanotechnology, I used to call it the killer app, but that's wasn't such a good moniker for health technology. The quintessential application are nanobots, nanorobots, small devices the size of blood cells that go inside your body and perform therapeutic functions. And if that sounds very futuristic, it won't to the crowd at this conference. You only have to look at the other presentations in this conference to see that we're already doing very exciting things with the first generation of nano-engineered devices that are performing therapeutic functions already in animal experiments. Now, very often these are little devices, nanocapsules that can hold and release a medication. These devices will be 1 billion times more complex in terms of their feature complexity in 25 years. They'll have computers in them. They'll have intelligence. They'll be able to actually augment intelligently our immune system. Our immune system is intelligent. It's actually interesting how it works. You might wonder how these white blood cells can gain specificity against specific pathogens. They actually use an evolutionary process. They evolve a solution against specific pathogens. But it's a very slow process. I've actually watched one of my white blood cells attacking a bacteria on a slide, and it took about 2 hours. It's a very boring thing to watch. It was intelligent, but very slow and sluggish, and as is well known, our immune system is subject to all kinds of limitations, autoimmune disorders. We can create nanorobotic versions of this that can download new software from the internet to combat specific pathogens, won't be subject to autoimmune disorders, will be much stronger and much faster than our biological immune system, and that will be a very different era. That's the ultimate promise of nanotechnology.